Okay, everyone. Hey, everyone, this is Chen Dong Li. Today, I will talk about my case study, the final project in identifying the emotions from speech. The problem statement. So, I want to identify 7 emotions from 2,800 short speech using Toronto University Department of Psychology's data site. In most recently, emotion recognition from speech is it's actually a hot area of great interest for human-computer interactions. Um, exactly words, but delivered in different tones can be understood in totally different ways. So understanding emotions is great way to help develop natural language processing and better understand human speech. In this case study, I basically utilize a CNN model to identify the 7 emotions, including anger, fear, surprise, happy, um, discuss, and so on, from a very short, just 4 word sentences. The software technology, I use Anaconda and specifically Python 3, use Jupyter Notebook and all those my following um, package I use most frequently. The Windows in my computer is very old computer. It's 6 GB CPU and Windows 10 AMD. So the data, I got data from Toronto University Psychology Department. They provide, I can show you the data a little bit. They provide 200 target word in for each emotions, and there are 2 actors to speak those words in these 7 emotions. So, actor, for example, the old actor and young actors, they will say the word plus another word, like say the word bike, say the word bar, say the word base. There are 2,800 audio files in totals, and I will show you this database a little bit in the Toronto. This is the Toronto Emotion data site. You will find out, let's go into the Toronto Emotion data site. You'll find out all the file are not packaged well and then zipped in a easily download package. So the first thing I need to do is to download, script those videos, the audios, and label them in an organized way. Okay, let's see if we can play around the sample of the sentences. Let's go to the very top. Okay, um, let's start to play a random sentences. See if we can get anything. Okay, so this is randomly select from the 2,800 short samples, sentences samples, and this particular sample is from young actors, and this is the sad emotions. We can find out that the sample is not CD quality is 41K hertz HZ, but it's 24K hertz. Um, so let's play the emotion.
Say the word perch. Say the word perch.
So this is sad emotion from young actors. I'm not sure you can hear it, but this is let's see another one. This is angry. This is angry emotion.
Say the word vote. Say the word vote.
Let's try it old. See if we can get any old. Oh, this is old. Like the high.
Say the word sell.
This is old actor from.
Say the word sell.
Okay, let's come back to this. Um, the overview of the step. I will start from download the file like I mentioned before, and I want to explore the audio sample a little bit to find out the wave and the spectrum figures and see if any particular characteristic for each audio sample. And then I will play a random sample audio to generate the wave and spectrums and do the MFCC feature engineering to prepare the data and split the train then test set. Before the setup mode, I want to do the normalize and vectorize, reshape the training set test set that is um, paired up or matched up with the CNN architectures, and then I train the model and evaluate the model. So let's see. That's the audio sample characters from the old actress and young actress. And this left is the hyper emotions, and this right is the angry emotions. And we can find out the emotions, different emotions, different audio shape, and this is the spectrum of audio shape. And the we Zoran talked about this spectrum in the class. It's basically the intensity of the spectrum is the loudness of the speech. Um, to analyze the audio information, there are basically two ways. One way is you can do the audio, vectorize the audio, like do the audio featuring engineering, feature engineering. Another way to can translate the audio into text script, and you can do analyze the text. The way I choose it to analyze the feature, the vectorize of the audio, and using the MFCC to analyze that. Doran talked about this at MFCC when we learned this in our class. It basically, is the way to um, filter out the ultra high and ultra low frequency of our audio, and to mimic humans' perception of the speech. That way, we can reduce the computational powers and easily to calculate. So after do this FFCC feature engineering, I got these two different samples, MFCC spectral samples, and you can find out this is the surprise from young actor, and this is the happy from young actors. The sample patterns has significantly, clearly than the wave chart or spectral chart before. It's barely can see a lot of difference. You can see very clear difference between those two emotions, even though it's only from the same actress actually. Next, I want to do is to process, pre-process and prepare the data. So what I did is to we will talk about this part. Actually, a lot of code is from our class. Is to first need to organize the data in the labels, and split the train test sites, split the train test sets, and because the to do the MFCC, we need to maxed out or fix our dimensions, our two dimensions, 2D dimensions. To do the way to fix that is to give the feature dimension 2, the 34, the fixed dimensions. And also I normalize the training and the test side before the setup, before I run the models. Um, I didn't change much except very similar. I followed very similar procedures, the architectures from our class. Um, the way to do it is to I set up this 2D convolutional neural network, and set up three layers to connect 2D, and then do the max pooling using three dropped off to wide overfittings. And I use the metric accuracy. The loss function is the categorical cross entropy. So let's take a look at the result. Okay, the result is actually quite accurate. I think it's because of the sample. We can find out I use the 30 I poke, and I can get the validation accuracy about 99%, even just in the fifth I poke. Um, the maximum validation accuracy I get is around 99.8%, which is quite high. And considering there are only about 1120 sample size of the validation accuracies. There are only about 2 to 3 samples of the short audio file that was misclassified. So next thing I will do is I built this model accuracy chart and the model loss. You can find out it's almost equal to 1. And the loss of the model is quite minimum. And let's take a look at the prediction. Next I do is to do the spot check of the test set. Basically, after training the model, I got the model, and I want to use the model to predict the test set, see what's the if the result is aligned with the actual test labels. Let's test out. Okay, so this is the emotions from the prediction is discussed, and the actual is also discussed. Let's try another one. So it's like the emotion is a fear, and it's actual fear. Um, what about let's play the video and see if it's reasonable as we thought. So again, this is neutral from our predictions, and actually it's also neutral. Let's play the video.
Say the word goose.
It sounds like it really.
Say the word goose.
Let's do again. So this one is audio is fear, and from actual, and the prediction is also fear. Let's see if it
Say the word burn. Say the word burn.
it sounds like real fearful emotions. The last thing I did is the prediction error analysis. Prediction error analysis. Because the accuracy is almost about 1% at 100%. Only about the two three the maximum accuracy is 99.8 percentage, and there are only about 2 to 3 label that was misclarified. Let's check out what's the label that it been easily, not easily, but relatively easily to be misclarified. It take a little bit while. So okay, there we found out like the surprise and are the most relatively easy label to be misclarified, and we can find out also the happy can be misclarified as surprise, and surprise can be misclarified as happy. The last thing I want to talk about is the future work. So, what I would like to do going into the future. First, I want to um, get more various source of the audio speakers, and this data set only from two speakers. It's very limited. If we can somehow get more data from different various source of speakers that can potentially apply this application to the real world. That's my target, to really apply it um, to the reality, to the real. And another thing I would like to do is to translate the audio speech to the text and to the text actually, to the text, and to do the sentiment analysis based on the test script, based on text script. This will be you can take long sentences, and you can analyze more variety of video, and for this kind of data is easy to find compared with the emotional data. The last thing to do is to probably need to add noise. See if we can somehow filter out the noise and really deploy this artificial intelligence, data deep learning application to the real world. So now that's all my presentation about my final project about identifying emotion from speech. Hope you learned something from it. Thanks so much.